Hello, so this is the second video for week number 12, and I'm going to talk about the Prism software, which is a really convenient tool to develop the response spectrum. We already went over this application in the class, but I just want to go over it again. All right, so, and one of the reasons is some of you contact me that you have in trouble to develop the response spectrum for your entertainment package problem. All right, let's see. I'm going to share the screen. Okay, so first of all, you have to download the software. Go to Google, search Prism, P-R-I-S-M, and then response spectrum together. Then the first link will be the one you can download it, and it looks something like this. Okay, so when you just Google the Prism response spectrum and the first link, just click it and go below, then there is a link for the download the program and the manual as well. So just download it, install it on your machine. Then unzip the file, then you can have this as a preset. Okay, so double click the program. I don't know why this window is coming up again, but so this is kind of a typical the window, and there are three different kind of functions that you can do using this software. The first one, you can see the time history of your ground motion record in acceleration, velocity, and deformation. And the second one, you can run the analysis, the single degree of freedom analysis with that given ground motion, depending on different types of the stiffness model. And the third option is the one that you can develop the response spectrum. Okay, so to do that, we have to first load the earthquake ground motion record. So click open, and there is a folder called accelerogram, and this folder include all the preset and default ground motion records. So you have several different versions of it, and just click one of them. I'm going to call click the Kobe. And this is the second window popping up. So first of all, you have to determine the units of your data, and then depending on the format of your data, this is they call the NGA and NGDC format. So when I click it, I have to determine which is going to be the first line to read of the ground motion data. So the first four lines are about the data. So it is kind of explanation about the data. This is acceleration time history. The unit is G, right? And then the dt is the delta t, the time step. It is 0.02 second. So these are all the information about this data. And the database source is the pure strong motion database record. So anyway, based on this information, you can determine the raw data, the input, the units, and then the first line to read is going to be, in this case, 5, and time step delta t 0.02 in second. So I modify it, and number of data each line. So we have a total of 5 columns, right? So I'm going to change it to 5, and then click OK. Then you can see the time history of the acceleration, velocity, and displacement. And actually, velocity and displacements are just going through from the integration of these, right? So that's how we can see the time history of these ground motion record. We can do the analysis with different stiffness model if you want. So for example, linear elastic means there's a simple linear function for your stiffness, and the stiffness is going to be the slope. You can either determine the period of the structural system, or if you know the mass and stiffness separately, then you can do that too. So So when you quickly run the analysis, these are the time history of the displacement response, velocity response, and acceleration response with the Gobi earthquake that I just loaded with this 0.5 second of the period, okay? So if you want to find out the maximum value is automatically detected here at 5.88, and I mean the 8.88 second, the maximum acceleration is 2.149 or something like that. And if you'd like to see it as a tabulated format, you can click the value, right? Or force displacement graph. This is based on the force and the displacement, the force and displacement. And since we use a single linear stiffness curve, which is a straight line, it is just way back and forth on that line. So the third one, that's what we're gonna use it, because we'd like to develop the response spectrum to see the spectral acceleration. And by the way, when you are working on the most recent entertainment package, we have a 15 building types and building structures, and each one of them may have a different period, right? So what you have to run the analysis to develop this response spectrum using the given ground motion that I provided. And so this is elastic spectrum, just use that one. And number of the damping values, in this case, I just want to keep the damping ratio 5%. But if you like to develop several different curves on the same chart, then you can do that too. So 5%, 10%, 15% overlapped on top of it. I just want to go with the 5% one. The maximum period is will determine the maximum period of the building range. Okay, so when I run it, so it will give us the range between 0 and 4 second. If you like to focus on the 2 second or 1 second, you can just adjust this maximum period one. So these are the maximum, the response spectrum, the acceleration version, velocity version, and displacement version. And in my first video clip, I explained about the theory behind of this response spectrum. So how this software will develop this chart. So for your entertainment package, you have to run this and then find out the corresponding spectral acceleration, which is the maximum acceleration here, the y value, depending on the period of each individual building. And if you like to have it in a tabulated format, just click here. So probably you can find out the spectral acceleration, which is this acceleration value with the 5% damping, depending on the period. So let's say one of your building the period is going to be 0.3 second. Here is 0.3 second. The corresponding acceleration is going to be 1.91503 in G. Okay, so that's how we read this graph or get the value from this table. All right, so I think that's all. One thing I'd like to mention that the modified schedule that I uploaded earlier in last week, in week 11, there is an error. So I just want to mention that. So this is the one that, no, this is the new one. This is the one that I uploaded before, okay? And then as you can see, here we have week 11, that's fine. Week 12, 13, 14 is April 13th through 17, and week 15 is again, April 13th through 17. So this is wrong, okay? So don't follow this schedule. Instead, let me see. I uploaded another one under week 12 folder. So which is this one. So I modified the schedule it again to remove that error. So now we have week 11 through week 16. So week 16 is our last week, which include the review session and the final. And I raised the seismic fragility because that was already covered in our class, right? So this week I have response spectrum, Prism software, I'm going to go over the 2 example problems, and those are the topics for this week. Next week, we will have our review session for midterm exam 2, which will be the take-home exam. I'm going to talk more about that later this week. And then week 14, Monday is the Easter break, but Wednesday, Friday sessions will cover these. And the structural dynamics and building codes, we already covered them all mostly using the design codes, and we were able to find out, the base shears and the equivalent lateral forces. So I'm going to visit that again to make sure that you understand those, because those are going to be revisited during our PE practice problems solving later. And then the last topic that I'd like to cover is the seismic retrofitting techniques and some other techniques like base isolations and bracings to reduce uh, the, the, the ground demand. So those are going to be covered in the week 14. And then we're going to start to solve the PE practice exam problems and continue to talk about those in week 15. And those are going to be the last topic. So I just want to double check and make sure that everyone is on the same page. And so this is the end of the second video. And then I'm going to post 2 more videos for solving 2 example problems from your textbook. All right, see you later.